Assalamu alaikum. Today is our second lecture of DSP, which is about the basic introduction of signal and system. As in the previous lecture of DSP, we have studied about what actually the DSP is, digital signal processing. Now the second step is the basic introduction of signal and system, which is used in DSP. Signal is actually the variation of one parameter with respect to another parameter is signal. And then comes system. System is the process which work on a signal to create another signal, such as we have an input signal. When we pass it to the system, it processes over the signal and create an output signal. Then forward we have studied about today about the basic operations, which are flip, shift and scaling. We will talk about each of them in detail. In the first function we have flip. In the flip we have input signal xn. We have different values over the points 1, 2, 3, 4 and on the negative side -1, -2, -3. The value is -1, 2 and the 1. Here is the -1, -2 and value is 2. The flip command, what flip command does is the flip function. We have the output signal yn. As we previously discussed, when we pass the signal from the system, it works over the system and generate another signal. So here the system generate signal yn, and yn actually the inverse of xn, which is x minus n. In x minus n signal we have the flip command, so all the positive values go towards the negative side and the negative values goes toward the positive side. Totally the signal flips up. Next we have the shift operation. In the shift function we have input signal xn have different values over the indexes 1, 2, 3 and on the negative side -1, -2 and -3. In the shift operation we have two operations. One is for advanced values and one is for delayed values. When we apply the function xn plus 2, the output signal is yn, which is equal to xn plus 2, which gives us advanced values. The index moves over the left side on the graph. And when we apply the function xn minus 2, then we get the delayed values. In the delayed values, our index values move towards the right. For example, when we apply the function xn plus 2, then index n plus 2, for example, we want to calculate the value for y minus 4. Put n is equal to -4 and adds plus 2, which is equal to x of minus 2. X of minus 2 is equal to 1. So at x of minus 2, value is 1. So at y minus 4 we have the value 1. In the same manner we calculate all these values and our graph shifted towards the left. For example, at 0 here we have the 0 value at point 0, but now graph shifted towards left with the index point 2. So we have 0 value over -2. Next we have the scaling function. In scaling we have the input signal xn. As we are already using, we have different values over the indexes positive side on the negative side. In scaling we have the command let's suppose yn is equal to x of 2n. In scaling, remind one thing, when we multiply with the integer, then our signal shrinks, and when we divide with the integer, our signal expands. First of all we have the shrinking example, then we will see the expanding example. In shrinking, when we multiply with 2, so signal shrinks. First of all, y of 1. For y of 1, x multiplied 2 into 1, x of 2, which is equal to 2. Now for value y value 1, we use the value of x at 2, and for the value of y at 2 we are using the value of x at 4, and for the value of y 3 we are using the value of 6. So our signal shrinks. As in x of n, our signal starts from 0 to 6 and on the negative side 0 to -5. But in this shrinking, when we apply this command, our signal shrinks, and on the right side from 0 to 3 and on the left side 0 to -2, because we have no value of x of n at -6, so there is 0 at -3. Now we have an example of function. We have the command yn is equal to x of -2n plus 3. Previously we discussed about the three functions, flip, shift and scale. Now we apply all these functions collectively over a single input signal, which is x of n. Then in this command, the order which we have to follow is shift, flip and scale. We have to follow the order shift, flip and then scale. First of all, we have to shift the signal with 3, then flip the signal with -n and then scale the signal with 2. So we have to generate three functions. First of all, z of n, which is equal to x n plus 3. It shifts the signal. Then for the next we make the function for the flipping. So it flips this function. Now the flipped it function, we have to scale this function. So for this, y of n is equal to z of actually omega w of 2n to flip this function. So in the end, lastly, we have this collected function from the shift, flip and scale. As we previously discussed about the shrinking and expanding. So in expanding we have one problem. When we expand the signal, for example, we have the command yn is equal to x n by 2. When we apply this function over that signal x of n, then the resultant signal we have the values at 2, 4 and 6. Over these values 1, 3 and 5 and -1, -3. Over the odd values we have the value 0, which lost our information. Then the question is how we can remove this error. It is actually the error because we have the information over these points, but when we expand our signal, the information lost. So to overcome this error, we have different techniques. For example, zero order hold, first order hold and second order hold. Now we'll discuss one of them one by one. First of all, we have the zero order hold. In zero order hold, we putting some values of amplitude sample if the sample amplitude is 0. Means that where we have the zeroth values, we take the value of previous sample over that sample. So in this manner, at -3 we have 0 value, so we take the value of -4 at -3. In the same manner, at -2 we have 1 and -1 at 0, so we take the value of -2 over the -1. In zero order hold, we have the function of derivative fx plus h is equal to f of x. We take only the 0th value. In zero order hold, we have some ambiguities, but on the next word we have first order hold. In the first order hold, Taylor series involved. In Taylor series expansion, we have first derivative involved. So with the first derivative, slope is involved. Slope y is equal to y2, m is equal to y2 minus y1 over x2 minus x1. Slope involved, so we take the averaging of two samples, which is the value of the middle sample. So in this manner, the first order hold is applied. In the next one, second order hold. In the second order hold, 3 samples are required. In previous we have 2 samples, but in second order we have 3 samples. So the Taylor series expansion is f of x plus h first derivative of function and h square by 2 factorial second derivative of the function. It is also an averaging of the signal. It's a curve wave signal. We take the 3 sample values and it makes a curved sample signal. Then lastly, we have special signals which are mostly used in DSP, digital signal processing. One is unit impulse and other one is unit step. In unit impulse, it has only one value at 0. When the function value has 0, then its value is 1. Otherwise, all values, it has value 0. The next one is unit step function. Unit step function has one value over 0 up to infinity. For the negative values, this function is 0. In the last part of the today's lecture is common signal decomposition. In common signal decomposition techniques, we learned about different techniques: impulse decomposition, step decomposition, interlaced decomposition and Fourier decomposition. And we have even signal and odd signal. In impulse decomposition, step decomposition, and further discuss about these techniques in details. When the impulse decomposition takes only one value, and step decomposition it takes every step values. In even signal and odd signal, even signals are symmetric and odd signals are non-symmetric. It is proved with the examples. We are using these formulas as we have taken the input signal in previous examples xn. When take the xn and the flip of x minus n, add both signals and divide by 2, then it gives the symmetric form of signal. And in the x odd, when we take the xn function and the flipped function and subtract these two divided by 2, then it gives the non-symmetric function of xn. Thanks for watching.